Hello, Mr. Price here, and here is the 6th video on the M2 June 2005 paper. This one is all about powers and work done. So let's have a look. So we've got our car of mass 700 kilograms, and it's travelling up a hill at an angle. And we know its speed at a particular point P, and we have a point Q, which is 400 meters further up the hill. And we also know its speed there as well. Okay, and we're going to the first part of the question. We want to find out the work done by the car's engine, ignoring any resistances to the car's motion. Okay, so we're going to first do a diagram of what's going on. So here's my angle. So here at the point P, I know my car is travelling at 20 meters per second, and then at point Q, my car travels at 15 meters per second. And I know that this angle here is 5 degrees. Now, we're being asked for the work done of the car. So the work done is the change in energy. So work done of the whole system, which is part of the car, and work done by gravity, because we're working against gravity here with the angle, will be equal to the change in kinetic energy. Okay, this is quite important. You may see this a different way, but I just want the work done by the car only, and the work done by gravity is working against us. So this is going to be taking away some of our work done from the car to generate this change in kinetic energy. Okay. Now, I can work out my change in kinetic energy because I have my different speeds here. So my change in kinetic energy is going to be half mv squared, so half of the car 700 kilograms, so 700 times 20 squared, 15 squared, sorry, because it's a change, so KE2 minus KE1, so half of 700 times 15 squared minus half times 700 times 20 squared. And we should find that our kinetic energy has gone down by 61,250 joules. Now, the work done by gravity is basically going to be our change in gravitational potential energy, mgh. Okay, so we don't know the height it's increased by, so we have to do a small trig diagram here. So we know we've got a 5 degree angle, and it travels, how far does it travel? 400 meters? 400 meters. Okay, so we can find the height easily enough. So sine of 5 degrees is equal to the height over 400. So the height is therefore 400 sine 5. So let's work out the work done by gravity. So the mass is 700 times by 9.8 times by 400 sine of 5 degrees. And this gives us a work done by gravity of 239,155 joules. So that means the work done by the car minus 239,155 is equal to our negative 612,050 joules. So doing some rearranging now, the work done of the car is 177,905 joules. And that's this part 1 done. And obviously I think in your exam paper it wants you to round to 3 significant figures. So 178 kilojoules. Okay, now for part 2. We now have resistance to the car's motion as a constant force of 200 newtons, and the acceleration of the car at q is 0. We want to show that the power of the engine as the car passes through q is 12 kilowatts, correct to 3 significant figures. So I'm only asked to find a power. So power is work done over a particular time, and we know that work done is a force times a distance, and a distance divided by time is a velocity, so force times velocity. Okay, so here's my car. There's a driving force of F. There's a resistance to the car of 200 newtons, and then we also have gravity working against us at 5 degrees, and that is mg. So we were told earlier in the question that at q the acceleration is 0, so therefore we're in equilibrium here. So we can work out the force if it's in equilibrium. So the force minus 200 minus mg sine 5 degrees equals 0. So after solving this, we should get a force equal to 797.89 newtons. Now we have a force and we have a velocity. So we wanted to find the power. So power will be equal to 797.89 multiplied by my velocity at point Q, which was 15. Wait, so was that meant to be at point P? I don't see point Q, so times by 15. If I do that quickly with my calculator, 797.89 times by 15 is 11968 watts, which is approximately equal to 12 kilowatts. Job done. Okay, and then fortunately for us, part 3 is not too dissimilar. Okay, so now we've got the car's engine at P is the same as Q, so we've got the same power. We want to calculate the car's retardation at P, so basically the acceleration or the negative acceleration at point P. So we know at point P the power is equal to the force times velocity. The power hasn't changed, so I'm going to try and keep my power as accurate as possible. So 1196 8 equals the force multiplied by the velocity, and at point P it was travelling at 20 meters per second. So the force of our car is, just need to do the calculation for that, 11968 divided by 20. So our force is 598.4 newtons. Quick force diagram. Five nine 8.4 200 MA at an angle 5. So using F equals MA, 598.4 minus 200 minus mg, the mass is 700, so minus 700, lots of 9.8 sine 5 equals MA. And we know that M is 700, so after some solving you should get an A value of negative 0.285 meters per second squared, which is what we wanted as retardation. And that's question 6 all done. I hope that was useful.